Welcome back to DailyTech Edu. Today, we are laying the foundational engineering blueprint for your career in cloud, cybersecurity, and system administration. We are breaking down the core identity of Linux, deconstructing the system architecture, understanding the critical relationship between the kernel and the GNU toolchain, and navigating the professional distribution landscape. When most people decide to learn Linux, they make a critical mistake. They jump directly into memorizing terminal commands without ever taking the time to understand the underlying operating system architecture. Skipping these foundational concepts sets you up for failure. It leads to severe confusion in production environments, leaves you completely unable to troubleshoot real-world system errors, and creates a dangerous dependency on copy and paste command sheets. True engineering proficiency requires a system-first mindset. You must understand the architecture first and the command syntax second. Before we look at Linux specifically, let's define what an operating system actually does at a structural level. An operating system serves as the critical abstraction layer between physical hardware assets like your CPU, RAM, and storage disks and user applications. Its primary responsibility is resource allocation. It acts as the master coordinator that manages system memory, schedules CPU processes, organizes file systems, and strictly controls hardware access. If you are aiming for a high-income IT career, you need to understand that Linux powers the world's most critical infrastructure across cloud platforms, enterprise data centers, cybersecurity tools, and mobile ecosystems like Android. The market reality is absolute. The vast majority of back-end web servers and enterprise cloud networks run entirely on Linux distributions. Beyond its ubiquity, Linux offers unmatched open-source power, giving engineers full control to inspect, modify, and deploy code at every layer. Combined with a battle-hardened permission model and robust process isolation, it remains the definitive choice for mission-critical deployments globally. This brings us to our major point of clarity. What exactly is the kernel? The kernel is the absolute heart of the operating system. It is the lowest layer of software that interfaces directly with your physical hardware components. Its operational duties are fundamental to the system's life. It manages execution tasks, schedules CPU cycles, partitions physical memory blocks, and handles hardware communication via device drivers. Every single application, daemon, and administrative utility running on your system relies entirely on the kernel for execution. The architecture of the kernel is engineered for absolute system stability. By enforcing strict boundaries, the kernel maintains system uptime and prevents poorly written user applications from compromising the underlying hardware layer. This creates complete fault isolation. If a user application crashes or experiences a segmentation fault, the kernel cleanly terminates that specific process while keeping the rest of the system online. However, if the kernel itself encounters an unhandled exception, the entire system halts, known as a kernel panic, to prevent data corruption. It achieves this through strict privilege separation between kernel space and user space, ensuring all communication with the hardware is controlled and auditable. To separate yourself from casual users, you must understand a key historical and architectural truth. Linux by itself is not a complete operating system. The Linux kernel is strictly a hardware communication engine. It contains no interactive terminal shell, no file utilities, and no user environment on its own. To build a functional system, you need the GNU project, which provides the essential system tools, compilers like GCC, libraries, and the bash terminal shell itself. When you merge the Linux kernel with the GNU toolchain, you get a complete, production-ready operating system used worldwide, formally, and correctly known as GNU/Linux. Because the core GNU/Linux components are open source, it allows for what we call the distribution model. A Linux distribution, or distro, is a complete operating system package where an organization bundles the Linux kernel, GNU tools, additional system software, and a dedicated package manager into a single deployable image. Different organizations engineer these distributions to target specific corporate, security, or infrastructure requirements. They all share the same core kernel engine, but they are customized for entirely different purposes. Let's look at the major distributions you will encounter in the enterprise landscape. First is Ubuntu, which is highly popular for cloud server deployments and developer environments due to its widespread adoption. Next is Red Hat Enterprise Linux, along with its binary-compatible counterpart, Rocky Linux. This is the global corporate gold standard for hardened enterprise environments and serves as the native platform required for the RHCSA path. For cybersecurity professionals, Kali Linux provides a specialized environment pre-bundled for security auditing and penetration testing. Finally, Arch Linux offers a minimalist, rolling release model for engineers who want granular customization. Remember, they share the same core kernel, but they are engineered for distinct use cases. Now that you have a clear mental model of how an operating system is structured, we are ready to accelerate our technical depth. In our upcoming modules, we will dive deep into Linux architecture, exploring the boundary between user space and kernel space to see exactly how processes and the kernel interact at a systems level. Make sure to subscribe and let me know in the comments which career path you are targeting. See you in the next module.